Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the significant figures with applications. Okay, so first we are going to learn what are the significant figures, rules of significant figures, rounding of the digits, and after that the applications. From there question used to come in a competitive exam. Okay students, so let's start the video. So let's see here significant figures with the application. So kindly see here, significant figures are those digits in a measured quantity which are known reliably or about which we have confidence in our measurement, plus one additional digit that is uncertain, or we can tell doubtful. That means a significant figure is made up of two components, one in which we have the confidence and the one last digit that is the uncertain or doubtful. Okay, let's see with the example. So students, you can see here the example. See, if length of a rod is measured by screw gauge, okay, and their readings are 5.456 centimeter, 5.453 centimeter and 5.459 centimeter. Okay, then in this measurement, you can see very well, if you will see that here all these three, this measurement and this measurement, you can see very well after decimal how many digits are there? 3 digits. That is only possible in a screw gauge because the least count of the screw gauge is the 0.001 centimeter. Later we will have no problem. But if you see here this three readings, in all these 3 readings the 3 digits are common. What is that? 5.45. That means here in this measurement 5.45 are reliable digit. That means we are very confident in this. And after that this 6, this 3 and this 9, you can see in this 3 measurements these 3 are different digits. Okay, so this 6, 3, 9 are uncertain digits or a doubtful digit. So students, I hope so this is very clear. That means in significant figure, one is the certain digit, that is the very common in the measurement, and after that one is the doubtful digit, like this 6, 3, 9 in 3 measurement. Okay, because the length is measured by 3 times by the screw gauge by a single student, or 3 students are there, they have taken 1 by 1 reading, anything is okay, but we have taken the 3 readings. Okay, great. After the students, we are going to see the rules of significant figure. Okay, so let's see one by one rules to determine the significant figure. So see here, first one, all non-zero digits in a number are significant, okay, no matter where the decimal point is. Okay, all non-zero. So I can write here, see if I talk about here the first example, and let's take it is given here 3.225, now all non-zero. So here what will happen that here how many significant figures are there? We can see very well 1, 2, 3, 4. That means students here there is the 4 significant figures. Okay, after that, for example, if I write here like this 32.25, I have just shifted the decimal. So here also how many significant figures? Same only 4 significant figures. Is it? So I hope so you have understood very well all non-zero digits in a number, and this one is coming from the measurement. Okay, that means here there is, I am not writing anything, but students here some unit is there. Let's take here meter is there. Okay, so all these readings are coming from the measurement. Remember that, coming from the measurement. Okay, after that students, the second one, see, the zeros appearing between 2 non-zero digits in a number are significant no matter where the decimal point is. So here what will happen that here, if you talk about here the example, let's take for example, I am writing here, see, 101.3. okay, so here you can see very well this 0 is coming between 2 non-zero digits, but here also how many significant figures? All are significant, 1, 2, 3, 4. So students here 4 significant figures are there. How many? 4 significant figures. Similarly, if in case I am writing here like this, here see 10012.3. okay, so here how many significant figures are there? Even these zeros are also significant. Okay, so 1, 2, 3, 4, 5, 6. So how many significant figures are there? Just count the digits here. 6 significant figures are there. Okay, 6 significant figures. Kindly see very well, students, this one. Now we have covered the 2 rules. Okay, great. Now we can see here the third application. See here the third application. The terminal or trailing zeros in a number without decimal point are not significant. Okay, and if I talk about here the example. So students, here the example is, let's take for example I am writing here 15200. Okay, so here what will happen, that here these two zeros, decimal point and all is not there, no? They are the ending zeros, terminal zeros and all. Okay, so these zeros are non-significant. So if we remove them, how much will be left here? 1, 2, 3. That means these 3 are only significant figures. We can write here in this number 3 significant figures are there. Okay, similarly if I talk about here the second one, let's take this is given here, see 320100. Okay, so here kindly see and tell me how many significant figures are there. Again, these zeros are not significant, but this zero is the significant. Why? Because this zero is coming between two non-zero digits. So here how many significant figures are there? You can see very well. These are the significant figures. So here we can see here the students how many significant figures? The 4 significant figures are there. Is it? I hope so you have understood very well. Now after that students, let's go for the fourth rule. Now important, very important. See, if the number is less than 1, underline the word, if the number is less than 1, the zeros on the right of decimal point but to the left of first non-zero digit are not significant. Okay, let me write here the example. If I write here the first example, let's take what is given here, 0.00725. Okay, so here what is happening at here, these zeros are there, na? These zeros, what is there? Right of the decimal point but left of the non-zero digit 7. So this 0 is what? Insignificant. That means how many significant figures are there? You can see very well here students, 3 significant figures. Okay, and this number is less than 1. Okay, after that if I write here the, let's take for example the second one, again number 0 point, let's take here 0.00, I have taken here 7012. Okay, so here the students how many significant figures will be there? Again I am telling that here these zeros are non-significant. That means this one here. Okay, that means here how many significant figures are there? 4 significant figures are there. Is it, students? Kindly see very well now how we have done this, especially the number is the less than 1. Okay, great. Next one, very important, see, pure number appearing in the mathematical formulae have infinite number of significant figures. Again I am telling pure number. Okay, so let me write here the one formula. Let's take for example if I write here the area of square, no? One, not area actually, if I will take here the, okay, perimeter. Let me write here the perimeter. Okay, so perimeter, can you tell me here perimeter, what is the perimeter of a square? So perimeter of the square, if we write here, no, this is the square, is it? And if the side is A, what is the perimeter of the square? It will come here 4A. Okay, so here what will happen that here, the students here please, this 4 is the pure number. Now we have not measured and all, side we have to measure, but 4 is the pure number. That means in this number 4, how many significant figures? Infinite number of significant figures are there. Okay, infinite number of significant figures are there. Remember that pure number. Okay, great. Now students, next one, let's move for the next one. See, under the note, see here, as choice of change of different units should not change the number of significant figures in a measurement. Again I am telling, when the system of units are changing, we are going meter to centimeter or meter to millimeter, the number of significant figures in the measurement should not change. But you can see here, but in following example, this rule is failed. Actually it should not change, but means it should not, what is there, this rule should not be failed. But I will just tell the example, there you will see this rule will failed, but we will also learn how to overcome this. So students, if I write here, see, it is given here, let's take for example 1.000. Okay, and I am writing here the meter. Can you tell me how many significant figures are there? Can you see very well? Now decimal is there, so this all are significant figures. That means we can tell here there is 4 significant figures. Okay, After that, if I convert into the centimeter, 1 meter is the 100 centimeter. So decimal will shift here, 100.0 centimeter. Okay, that means here what will happen, that here also you can see very well the 4 significant figures are there. Okay, all zeros and all is significant. Now after that, if I convert into millimeter, so what will happen, that you see 1000 millimeter. Okay, here what is happening, that here the decimal point has lost. So if you will see here, there is the only this significant figure, because we know very well trailing zeros without decimal point are insignificant. So these zeros will become insignificant. How many significant figures are there? Only one significant figures. So what happened, that here actually when we are changing the units, the significant figure should not change. But here what is happening? It has changed. So to avoid this kind of error, we will represent a measurement in a which form? In a scientific form, in a scientific notation form. Okay, first we are going to learn that, then again we will come to this, and again we will rectify our mistakes so that this rule should be valid. The rule is that when the units will change, system of units will change, the number of significant figures should not change. Okay, kindly see here. Very well, is it? Great. Now see here. Next one, see the scientific notation, because the rule got failed now, so we have to learn this. See, scientific notation. The best way to remove such errors means the previous one, is a scientific notation. Okay, what is this here? In general form, scientific notation is represented by a into 10 to the power b. Okay, a into 10 power b here. See here, very well, a into 10 power b. Now, where a is any number lying between 1 to 10, that means a where 1 to 10, even 1 and 10 is also included, and b is any positive or negative exponent of 10. Exponent of 10 means the power of 10. Okay, great. Now students, the note. So here we have seen what? A into 10 power b. So see here, please see. First one, b is called order of magnitude of a number. What b is called? Order of magnitude of number. Okay, and this 10 to the power b is called order of number. Okay, so here students, can you remember that here this term, very very important. This is the order of magnitude and second one is the order. Okay, so students, you can see very well in a into 10 power b, b is the order of magnitude and 10 to the power b is called what? Order. Okay, great, great. Next one, students, can you see here? Now we are going to learn what is the order of magnitude. Can you see here? The order of magnitude gives us an estimation of the magnitude of the physical quantity. Again, I am telling estimation of the magnitude of physical quantity. So can you see very well? See first one, when the number is 1 to 5, see here please, a greater than or equal to 1, less than or equal to 5, then order of magnitude is b, and 10 to the power b is the order. Okay, let's take for example, if I write here speed of light, you know very well, now this is a very common term. So speed of light, what is there, students? 3 into 10 to the power 8 meter per second in vacuum or air. Okay, so here you can see very well, if I compare this with a into 10 to the power b. Okay, so you can see very well the value of a is how much here? 3, and the value of b how much is there? 8. And see here, this 3 is coming between 1 and 5. So here what will happen, that here in this situation, if I write here the order of magnitude is what? B. That means we will write here order of magnitude of speed of light is what? B. That means 8. Okay, how much? 8. After that, what is the order? Order is means 10 to the power b, and we can tell here 10 to the power 8 is the order. 10 to the power 8 is the order. Is it? Great. Now students, second one. In second one, what is there? See, if a is here, kindly see here please, this is the 5. Okay, this is the 5. If a is greater than 5, less than or equal to 10, then order of magnitude is b plus 1, and 10 to the power b plus 1 is the order. Okay, so students, here also if I write here the example, let's take for example capital Na. What is capital Na? In chemistry, very common, Avogadro number. So here please, if I write here 6.023 into 10 to the power how much? 23. 10 power 23. Okay, so students, if I will compare this with how much, again I'm telling, see, a into 10 to the power b. Okay, compare both the sides. So here what will happen that here, students, can you see very well, this a value is 6.023 and b value is how much, 23. Okay, so in this what will happen that here you can see very well, this rule is valid, a greater than 5, correct na, 6.023. So here what is there, the order of magnitude is b plus 1. So students, here I can write here, see, order of magnitude or OM, order of magnitude, how much, b plus 1. So b value how much here, 23. So 23 plus 1 how much, 24. Order of magnitude is the 24. Okay, after that next one, if I write here the order how much here, 10 to the power b plus 1. That means here we can write here 10 to the power 24 is the order, because 23 na, we will add here 1, so it will become here 10 power 24. So students have to be very careful the a value, whether it is between 1 and 5 or between 5 and 10. I hope so this is the very clear to you. Is it? Great. Next one, students, we are going to learn here rules for rounding of a measurement. After learning the significant figures, we have to learn this, then only we can understand the applications in a very proper way. Okay, so kindly say very well, to represent the result of any computation containing more than one uncertain digit, it is rounded off to appropriate number of significant figures. And we are going to learn now the rules. The first one, see, if the digit to be rounded off is more than 5, then the preceding digit is increased by 1. So let me write here the example. Let's take for example, if I am writing here, see, it is given 5.627. Okay, so here what is called here, again I'm telling you here, this is called uncertain digit. Which digit? Uncertain digit. Remember that here very well. Okay, uncertain digit. And this digit is called the preceding digit. Okay, preceding digit left of the uncertain digit. So students, here you can see very well, if I want to round off this, so anyhow this is more than 5, so when I will round off this, preceding digit will be increased by 1. That means even I can write here 5.63. Okay, up to 3 significant figures. Okay, great. Second one, you can see very well, see, if the digit to be rounded off is less than 5, then the preceding digit is left unchanged. Okay, so if I talk about here the example, let's take anyhow it is given here 3.613. Okay, so here what will happen that here you can see very well, now the uncertain digit is 3. This is the less than 5. So here this one will be what? This one will be left unchanged. That means what will be there? It will be 3.61. Okay, kindly see here very well how we have done it beautifully. Is it? Great. Next one is, students, the third rule. Important. See, if the digit to be rounded off is equal to 5, then the preceding digit is increased by 1 if it is odd. Again I am telling, preceding digit is increased by 1 if it is odd, and is left unchanged if it is even. Okay, so we will see example one by one. First example I am taking, let's take for example 7.635. Okay, so here what is going to happen that, kindly see here, this uncertain digit is equal to 5. Then we will check this one. What is this? This is the odd. So when this is odd, what will be there? It will be increased by 1. So what this will become here? It will become here 7.64. This 3 will become what? 4, increased by 1. In this 3, what will be there? It will just become plus 1. Okay, great. Second one, what is writing here? Let's take for example, it is given here 7.645. Okay, so here also this is the 5 only, but now this digit is what? This digit is the even. So in this situation, even digit is what? Left unchanged, preceding digit. So what will come here? Here also it will come here 7.64. And whatever we are doing, this is all are the measured quantity. They are coming from the measurement. They are not a pure numbers. Okay, always with this number some units will be associated, maybe meter, kilogram, centimeter, anything. Okay, great. Now students, we are going to see here, see this question. Round off the following numbers up to 3 significant figures. Okay, so we are going to see here one by one. So see first one, what is given here? 2.523. All are non-zero digits. How many significant figures? 4, but we want to write up to 3. So this is the uncertain digit. You can see this is the less than 5. So according to rule 1, what will happen? This preceding digit will be left unchanged. So what will be there? 2.5 to answer. Is it? Great. Next one, if we talk about here, how much is given here? See, 22.78. So here what is happening that here? This uncertain digit is the more than 5. That means this preceding digit will be increased by 1. That means what this will become here? 22.8. This 7 will become what? This 7 will become 8. We will add plus 1. Okay, great. Third one, what will happen that here? Kindly see here. What is given? 36.35. What is given? 36.35. So here this is equal to 5. So here what is given here? This is the odd. Odd na odd. So this odd will become what? This odd will become even. That means it will become here 36.4. Okay, kindly see very well how we have done this question, and we have used the 3 rules of the rounding off. Okay, great. Now students, applications, because question used to come in exam from the application. Okay, so see very well. First one, in addition or subtraction, the final answer should have as many digits after decimal, as are there in the given measurements with the least digits after decimal. Now you read it 1 time, 2 time, no problem. Okay, but let's take, for example, I have taken here one example. Let's take 2 rods are there. We are going to add their length. So let's take, for example, one rod is the, for example, see 2.72 centimeter plus another rod is how much here? Let's take, for example, it is 1.1 centimeter. Okay, 1.1 centimeter. We are adding it. So here what will happen that here, if you will add, it will become here what here? 2.72 plus 1.1. It will become here 3.8. No, 7 plus 1 8. 2 plus 1 3 and 7 plus 1 8 and 2 as it is 3.82 centimeter. But this is not the answer up to correct significant figures. Why? Here how many digits after decimal? 2. Here how many digits after decimal? 1. But what it tells? The final answer should have which one? Least digits. What is given? Least digits as are given in a measurement. So here 2, here 1. That means final answer should have only 1 digit after decimal. That means what this will come here? It will come here 3 point. This 2 is the uncertain, less than 5. So we'll drop it. Answer will come how much here? 3.8 centimeter. I hope so. Very clear. Okay. Similarly, you can take the second one also. Okay. Let's take, for example, given 2.72 centimeter minus 1.1 centimeter. So here what will happen that here? Kindly see. When we will subtract it, it will come here 1.7 minus 1, 6, 1.62 centimeter. So here also students, what will happen that here? Again, this is the uncertain digit. No? Less than 5. So here also what is the answer? 1.6 centimeter. 1.6 centimeter. Is it? Kindly see very well how we have done it. Is it? Great. This is the first application. There we have seen digits after decimal. Okay. But now what will happen that here? Second application. In second application, see here, in multiplication or division, the final answer should have as many digits, as many significant figures as are there in the given measurements with the least number of significant figures. Least number of, here if you wish, we can write here least number of significant figures. No? Least number of significant figures. Okay. So let's take, for example, students, if I see here square, perimeter of the square. Okay, let's take here first area. Area of square. Can you see very well? So what will happen here? Let's take, for example, if I am seeing very well area of the square, what is the formula? A square. So let's take both are 1.2, 1.2. So multiply, you see 1.2 into 1.2. In centimeter I am taking. So here you can see very well how many significant figures? 2. Here also how many significant figures? 2. So what will happen that here in final answer there should be only 2 significant figures. Okay, because both are equal, nothing is least. So answer is 1.44 centimeter. But here you can see this is the less than 5. So 1.4 centimeter square will be the answer. Okay, because in both the measurements there is the equal number of significant figures are there. Okay, great. Next one after that. Second one I am going to take here. Let's take, for example, perimeter. Perimeter of a square. Now see here, perimeter of the square. So what we can write here, it is given by 4 into a. Correct? So see 4 and here a how much here anyhow? 1.2 centimeter. Correct? So here what will happen that here 4 into 2 means 4 2 is 8, 4 1 is 4. How much? 4.8 centimeter. But do you think how many significant figures will be there? This 4 is the pure number, infinite. This 1.2, how many significant figures? 2. So out of 2 significant figure and infinite significant figure, which one is the minimum? 2. That means final answer should have how many? 4.8 centimeter. I hope so students you have understood very well. Kindly see very well. Even this rule will be applicable for the division also, not a problem. Okay, great. Next one, now we are going to see the question asked in J 2025. Let's go through the question. So the question is, for an experiment, expression y equal to, this is given 32.3 into 1125 by 27.4. Okay, where all the digits are significant. Then to report the value of y, we should write, and here 4 options are there. So what happens that students, in these kind of questions, when the options are there, most of the time no need to calculate. By knowing the knowledge of the application of the multiplication or division or addition or subtraction, directly we can take the answer. Okay, so what will happen that here, if I write here, you can see very well, this 32.3 will have how many significant figures? It is having this 3 significant figure. Okay, next one, if I write here the 1125, this 1125 is having how many significant figures? 4 significant figures. 27.4 is having how many significant figures? This is having the 3 significant figure. Correct? So out of 3, 4, 3, which one is minimum? 3 significant figures. Okay, 3. So here you can see very well how many significant figures are there? 1, 2, 3, 4, 5. That means this cannot be the answer. Answer should have the minimum number of significant figures. That means minimum is how much? 3. That means 3. Here how many? Here also students 6 significant figures are there. That means this is also wrong. Here what will happen that here you can see very well 1, 2, 3, 4, 5, 6, 7. 7 significant figures, that is also wrong. But if you will check here how many significant figures are there, na? Decimal point is not there, trailing 0 is the insignificant. That means here how many significant figures are there? 3 significant figures. That means here this is the correct answer. So you can see very well, even without doing the multiplication or division, we have got the answer. Students, so I hope so very well. The application is the important. Okay, we have to just count the number of significant figures during the multiplication or division, and in the final answer just choose the least number of significant figures. Okay, great. Now see, this is the NEET 2022 question. The question is, the area of a rectangular field in meter square of length 55.3 meter and breadth 25 meter. After rounding off, the value for correct significant digits is how much? Okay, so what will happen that you can see very well. Here you can see students how many significant figures are there. If you will see here 55.3, that means 3 significant figure. Okay, 25, how many significant figure? 2 significant figure is there. Okay, 2. So you know very well the area is given by what? Length into breadth. Okay, so length into breadth, how much coming here? 55.3 meter into 25. What is coming here? Multiplication. I don't know what is the answer, but I know the rule. What is the rule? Minimum number of significant figures. Okay, that means here how many significant figures should be there? Here 3, here 2. That means this should have the 2 significant figures. Okay, so first let's check the option. See here 138. 138, that means here what is there? Only 3 significant figures. Wrong. Okay, next one, here 4 significant figure, that is also wrong. And here 5 significant figure, that is also wrong. Answer should have how many? 2 significant figure. Okay, so here 2 significant figure is there, and 10 to the power whatever is written, it used to be the insignificant. Okay, so you can see very well the correct option is here option D. Okay, so kindly see very well. So students, I have taught you the scientific notation. Now in scientific notation, what will be there? When the units will change, the significant figures will not change. Okay, so I am just going to the back side to just make that clear. Okay, so students, kindly see here what I told you, the choice of change of units should not change the number of significant figures, but here what happened? It has changed. So what will happen that here, because of this, we will write here in a which form? The scientific notation form. Which one is scientific notation? Okay, I should tell you this, scientific notation. Scientific notation. So here what will happen that here in this first situation, like 1.00 meter is there, no problem. 1.00 meter, how many significant figures anyhow? The 4 significant figure. Okay, this is important, that's why I am telling you. Next one, see here. Here what will happen that here in this situation, 4. But here what I will do here, this meter I will write here centimeter, but in a scientific form. So I can write here, see, 1.00 into 10 to the power 2 centimeter. How many significant figures? 4 significant figures are there. Okay. Now next one, if I write here, see, here only the problem came. But what I will do here, meter to the millimeter means I will not lost the decimal point. I will just write in terms of power. So what will happen that here, students, see, here I will write here 1.00 into 10 to the power 3 millimeter. So how many significant figures? Here also again 4 significant figures are there. So students, you can see very well, when we are writing the, means when we are converting the units, if we are converting in a scientific form, now we are using in a powers and all, this one, this one, this one, then the rules will not failed and all the things will be applicable. Kindly see very well. So students, I hope so this video you have understood very well. Keep studying, keep going.